got a full room. I like to see this. This is perfect. So yeah, Derek Manky. I've been with Fortinet for over 13 years. This is a little odd. I'm in the socks up here. Over 13 years. I come from a threat research background, working to create strategic solutions, right, that we can use for you as defense solutions, but also going above, the call of duty from a network defense perspective. And I work a lot in industry. I'm on an expert working group with Interpol at the IGCI Cyber Fusion Center in Singapore. We've had some good success working to actually, share intelligence packages and take down cyber criminal organizations. Also working with, on the steering committee with the Cyber Threat Alliance as well to share intelligence through vendors, even competitors in the industry, so we can level that intelligence and start integrating it into solutions for you. And you're going to hear about that today as I talk. The main theme of my talk is prime time for AI, subverting threats with intelligent expert systems. And I'm going to describe the concept of an expert system. I'm also going to describe how we have a very good opportunity right now. I think for once, we are not ahead of our time. If we look back into history, we've had so many good minds in history that are 50, 100 years ahead of their time. Unfortunately, I like to start off talking about this guy, Charles Babbage, 1837. We're not even talking 100 years ago. 1837, he created the analytical machine, which later was to be discovered to be Turing complete, i.e. the world's first programmable computer. Well, he was a mathematician, and this was mostly about, calculations, this machine. One of his apprentices, Ada Lovelace, who worked with him, saw a need even greater than this. She's widely regarded as the world's first computer programmer using that. There's even a language which I've coded in before called Ada Pro. She was regarded as the world's first computer programmer, and at the same time, she saw a need saying, why can't we just use these machines for more than just math? There's got to be more algorithms, right? More applications that we can apply to this. But unfortunately, the technology just wasn't there. She was stuck with the analytical machine. Great minds ahead of their time. This guy, very famous and popular guy, Mr. Alan Turing, he called an infant's mind an unorganized machine. He very much saw an infant's mind the same thing as an untrained computer. And he said, in order to train that mind, right, just like an infant, you need two main variables. You need discipline and you need initiative. Discipline alone was not enough to create what he called a uniformed machine, i.e. a grown-up infant or an organized machine. And the idea of the initiative was really what we refer to in our world as intelligence. Taking initiative, being able to feed data sets into discipline, which is algorithms in our world of computer science. Algorithms, if you just have an algorithm, it's going to keep on doing the same thing. If you can start taking initiative on these computer routines, feeding it new intelligence, where it starts to be able to apply new routines on top of its program routines, that's when you can start training that. And that's this concept that Turing talked about, training an infant's mind or an unorganized machine. And he saw the need for this, but again, ahead of his time. If we look at the history of AI, and by the way, I just picked up a copy. I didn't have a screenshot up here to put on because it was brand new, but Time Magazine just released a special edition on artificial intelligence. It's called The Future of Humankind. Great read. I suggest to read it. It does not talk about cybersecurity whatsoever, which surprised me. But it's so important if we think about what we need to do with AI, what we have to do with AI and expert systems, applied intelligence, and cybersecurity. If we don't do that now, and this is what I mean, we're in an opportunistic time, we're simply going to win. We're going to lose this war against the black hat attackers. Because I can tell you, black hat attackers are also investing into automation and AI on their end. It's a tool. It can be used for good or evil, right? Ahead of Turing, in 1956, AI research was formally founded as a discipline at Dartmouth College. Of course, then there's heavy investment from the US government, cuts after that. Then we started getting the modern computing era, right? When we saw PCs taking form. We had applications to AI, traditional applications starting to be used for medical diagnosis, for finance services as well. From there, we started moving into cognitive thinking, right, via IBM. Watson, as an example, at Jeopardy, when it defeated Keith Jennings, a good favorite of mine, and Brad Reuter, it used over 200 million pages of structured and unstructured data, right? But this is not cybersecurity. These are traditional applications that we've seen throughout the years. Now, why haven't we seen applications up until now for cybersecurity? We simply haven't had that need. If we look back to 1971, this is regarded as the world's first computer virus, creeper virus. This was written for the 10X operating system. It had one output. I'm the creeper, catch me if you can. And as I'm going to describe, and I'm sure as you heard just in the previous presentation, when we talk about machine learning and deep learning and artificial neural networks, it's all about features, right? How many different features can I look at to make a decision, is this bad or good? In this case, there's not that many features. It's one platform, one binary, one simple output line that it's doing. Not like these complicated APT attacks and malware that we see today. So there just wasn't a need, even though we had technology at the time that could apply to this. Just wasn't a need for cybersecurity to that. Why do we have a need now? And this is no secret. I'm not here to spread doom and gloom. We all know threats are just accelerating at a rapid pace. This is because of a huge expanding and flourishing attack surface, you know, with the world of IoT now and billions of connected devices, from smart vehicles which have 3G and 4G and LTE and Wi-Fi and Bluetooth connectivity. That attack surface is all integrated. And we're seeing an explosion of threats. Why are we seeing this explosion? Because black hats have already invested into automation on their end to be able to drive these threats to that attack surface. We're seeing, just from FortiGuard telemetry, we have over 3.3 firewalls shipped worldwide, 320,000 customers. We're seeing over 1.2 billion, the number keeps going, 1.2 billion in just 1 minute. Just 1 minute in cyberspace, we're seeing that many triggers on IPS sensors. And these are worms and attacks that are trying to exploit and worm their way into systems. We're getting north of 1 million virus samples in one day, potential virus samples. And as you'll see later, this is why we have to rely on AI on our end and the way that we've been training up our deep learning systems. We're using threat intelligence in the industry beyond just, again, as I said, working with integration into firewalls and cybersecurity solutions and our security fabric. We're doing works directly with vendors, zero-day security research. We're trying to actually beat black hat attackers to their game. So I wrote our responsible disclosure protocols. We're doing white hat ethical hacking to be able to close these security holes before the black hats do. Working with vendors like Microsoft and Adobe and so forth. We're working with National Computer Emergency Response via FIRST as well, to share intelligence. Public-private relationships are really important to try to make it more expensive. This is a key theme I always want to talk about. How do we make it more expensive for cyber criminals to operate, right? We do that via a couple different techniques. We can do that by trying to shut down cybercrime. We can do that by sharing threat intelligence to block these attacks. And we can also do this through integrated intelligence into automated solutions like our security fabric, which I'll explain what we're doing. As I said, we're working with Interpol and also National Computer Emergency Response around the globe. So, why do we need expert solutions? As I said, we have so much intelligence happening, so many attacks, as you can see on that attack surface, happening out there. How do we challenge that? So I author our threat predictions. I like to be in like a thought leader, visionary type role, and I author our threat predictions every year. These ones we actually issued last year, but I like to use them as a tool to explain the movement we've seen on the threat landscape. The idea here is that threats are going to be intelligence, autonomous, and difficult to detect, right? So if we look at what's happened, the idea and the concept here last year when we looked for is, we said, right, we're probably going to start to see some more threats appearing on the threat landscape that are automated and act in a human-like fashion, right? Going back to what I talked about with Turing, this is about using discipline and initiative. This is the idea that threats are not just going to have discipline, their own algorithms. If we look back 10 years ago, threats are very dumb, right? They're what we call zombies, infected machines. They're bots. They wait for an attack command from the attacker. The human black hat attacker has to get involved. They have to say, go launch this DDoS attack, go try to get into this network. This is a Lockheed Martin kill chain cycle. If you get into the network, report back to me, and then I'm going to tell you what to do next. So the idea here is that the black hat is going to start to be taken out of the equation as this code starts to learn on its own and have different attack paths that it can take, right? And we saw that this year with the Hijim botnet. This is an intelligent IoT botnet. It supports over 9 platforms. It's cross-compiled, including x86, so the PC, ARM, right? All these different IoT devices it can spread to. It's intelligent in the sense that it comes with custom payloads that it can attack and say, okay, right, I'm going to fingerprint you. I'm going to see what sort of platform you are. And then I'm going to try to execute the right payload. I'm going to deliver you this payload because I know I've done reconnaissance and I know this is right for you. Again, something that a black hat attacker would usually have to do. We see over 30,000 detections per day that's happening just on this IoT botnet alone. There's going to be more developments with these type of threats definitely moving forward as well. 20 billion devices are the weakest link in the cloud. If we think about cloud attacks and cloud security, what are we thinking about all the time? We think about things like data center attacks, breaches, right? Databases, web attacks, SQL injection, cross-site scripting, server farms, this sort of stuff. Happens all the time, and it's something, as we see in the news almost every month, that we have to definitely be aware of. But beyond that, with IoT, these are the weakest link to the cloud. These are things that connect up to the cloud that, as we all know, there's no patches in sight. We have to treat these in a zero-day IoT environment. And we have seen an explosion in this, particularly on mobile. Just this year alone, we went from 2.2% of our entire virus collection being mobile threats to over 10% now. And that virus collection is big, by the way. We have almost a petabyte. And we're getting, like I said, north of 1 million virus samples in a day. But beyond that, we're seeing active attacks. We do a lot of threat intelligence work and telemetry, looking at what are the biggest attacks happening out there, how do we properly address them. I meet with a lot of CSO across the globe in various verticals, and the number one problem they say to me is, Derek, there's way too much noise out there. We're getting security logs firing left, right, and center. We don't have all the resources, how to respond to these. How do we take a proper approach? And so we're working with them to provide threat intelligence reports and to contextualize information and say, here are the top attacks on your network, here's why they're critical, here's how to respond to them, right? And this is the sort of intelligence that we do. If we look at just IoT alone, we're getting, in a month, north of 100 million attacks on consumer-grade routers. They're the number one culprit right now. Consumer-grade routers you can just buy off the shelf. DVR, MVR devices, printers, NASs, these are all very active as well. So it's here, right? This world of modern attacks and all of that noise that's happening out there. Another prediction we issued was that ransomware was just the gateway malware, the gateway to malware. Ransomware has been around since 1989. It's called the PC cyborg virus, and it's on DOS operating system. So it's not new, right? It's been around a long time, but there's so many different developments that's happening in ransomware. So the idea here is that there's going to be way more monetization beyond just the traditional model of ransom attack, i.e. I'm going to send you a phishing email, you get infected, you pay a Bitcoin, even though Bitcoin is $6,000 now. That's the idea, that there's going to be more targeted attacks happening in ransom of services as well. We saw that this year. There's a web hosting provider in Asia Pacific. They paid $10 million in ransom to get access back to their web services. Why did they pay $10 million? Because they're losing more revenue. They're bleeding more than $10 million when these services were held up for ransom. And that's what we're starting to see as key reconnaissance attacks on big value revenue services as well. And of course, this year we saw the birth of a new threat of what I'm calling a ransom worm. This, of course, probably everybody's heard about it here because it's all over the news, was WannaCry and NotPetya. It is a generation and a breed of threats that use worm technology, i.e. using hot exploits out there, in the case of WannaCry it's Eternal Blue, to spread into systems, infect those systems, with malicious payload. If we look at worms of the past, they weren't connected with ransom, but now we have something that can spread fast and furious through this huge attack surface and use a hot exploit, which creates a very big problem. So we're seeing a lot of activity on the ransom front as well. And finally, this one's no secret, but something we have to address and talk about. Technology will have to close the gap on the critical cyber skills shortage, right? This is a global epidemic there, and that gap is just going to continue to get larger. We're working to fill that gap. I work on program advisor committees with faculty at universities. We have a 40 Academy program where we're actually injecting curriculum into universities to train them on cybersecurity so we can hire more jobs, which is very important. But at the same time, that gap is always going to get bigger. And how do we fight that? We need automation. We need AI. Otherwise, we're going to lose that war. But we do need good people and human experts on that end. And going back to the point I said before, most customers I meet with, and even up to large enterprises, there's always going to be limited resources, right? So what we can start doing is applying expert solutions to not lay off or fire, but repurpose good talent you have in your organization to do more complex tasks while the mundane day-to-day operations can be replaced with automation and with artificial intelligence solutions. Just a quick 101 on machine learning. Of course, there's supervised, unsupervised. You might have heard about some of this earlier today. Supervised learning, this is something where, in our case, we have a large global SOC. We have over 200 experts on FortiGuard. So FortiGuard is just our threat intelligence service worldwide now. Our experts are training our systems. They're guiding them, right? Just like going back to Turing and that infant's mind, training those machine learning solution sets based off expert knowledge. So it uses a tag, has the input or output, is this malicious or clean? And this is in the context of cybersecurity, of course. Unsupervised is using no tags, right? This is something much more meant for anomaly detection, clustering, algorithms, trending, forecast, this sorts of things as well. If we go back to the concept of features or a tell, right? If I were to tell you, I'm thinking of an object. Let's play a guessing game, okay? I'm going to give you seven different features about this object. Can you guess it? Well, let's see, right? So if I first tell you I'm thinking of an animal, that's one feature. But the degree of accuracy to what you're going to guess on this is going to be pretty low for probability. It's a huge field, right? As we keep going and I say, okay, this is a mammal. It's got 4 legs, gray fur. Now that's going up to maybe a 40–50% range, I don't know. But this is the way human inference works with the features as I give you these features and we try to identify what object that is. As we start to give more features, we can narrow it down. Around 10 pounds, it's got a short tail and long ears. Now maybe the long ears give it away here with the icon. I'm thinking of a rabbit, okay? But as I get even to 7 features on an object like this, that degree of probability of how you're going to accurately guess what this is increases quite significantly. That's not the case in our world with virus analysis, right? When it comes to viruses, we are talking not about 7 features to identify an object, a virus. We're talking about billions and billions and billions of features. Literally, we've created over the course of 5+ years now. And you can't just set up a machine learning system overnight. You can't just throw money at it and say, I'm doing machine learning. It's just like a toddler and an infant is not going to become a grown adult overnight. Going back to Turing again, this is the concept you have, and it's absolutely bang on with what we have to do with cybersecurity. So we've created something called a self-evolving detection system. And this system is a supervised system that we use our human experts to train with, right? Guided with virus samples. And as I said, this is a system that over the years has been trained on billions and billions and billions of features. We're well past that multi-billion mark. And over the course of the 5 years, it's becoming so accurate now, we've had tremendous results with this, that the false positive rate is very, let's say, acceptable. And in our industry, that's a big thing, right? Even if you have a false positive rate of 0.1, that's very bad, right? Because in the white hat world, if we do one thing wrong and we hit a false positive, that could interrupt your revenue, your critical services and systems. And that's the challenge we face, by the way, when it comes to this war on AI. If we do one thing wrong on the white hat side, it's very bad. If the black hats do one thing wrong, they don't care. They can do 100 things wrong, 1,000 things wrong. They're not bound by rules, and that's a challenge we're in this war with. The idea of this system is that as we feed it more samples and input, it's able to extract more features, right? Through different layers. This is A and N concepts where everything is connected via nodes, right? Weights and layers. And as it learns on this, and again, we're talking 1 million plus samples a day that are going through these systems, it's able to start sorting those into malicious or clean buckets. Now, day one when we set this up, it's not going to be saying it's not going to have a very high degree of accuracy, and that's why I said we can't just set this up overnight. But as time goes on, the feature sets improve, we get more features, we get more confidence on features, and a more accurate separation of that malicious or clean set. So, going to the expert system. So that's just learning, right? And this is a huge problem in the industry, is that we can learn, but if we just learn and we don't do anything about it, that's a big problem. And we've seen that day to day in these data breaches that happen. And that goes back to what I was talking about, these CISOs I talked to. There's so much noise out there. How do I properly respond? This is what we call actionable intelligence, or crossing the last mile. And so you can have machine learning systems, but how do you actually enforce that, reduce your false positive rate, and enforce that to stop these attacks? This is the idea of what we're doing, right? I'll read this verbatim, okay? Expert system, a piece of software program using artificial intelligence techniques. Such systems of databases, use databases of expert knowledge to offer advice or make decisions in such areas as medical diagnosis, stock exchange. Again, this is traditional implementations of AI or expert systems that have been done in the past, but it's just starting to happen in cybersecurity, and that goes back to what I talked about, this opportunistic time. At Fortinet, we've created the security fabric. This is a brilliant thing, I can tell you. I come from an engineering background. I love this, and that's why I've been here 13 years. What we're doing with the security fabric is interconnecting our product to talk to each other, machine to machine. Our sandbox talks to our gateway. Our mail appliance talks to the gateway saying, the mail appliance will talk to the sandbox saying, okay, I'm going to send you some information. I'm going to wait for you to sandbox it. I'm going to get that intel back, and then I'm going to make a decision. That's that last mile problem. Instead of having some administrator looking at a sandbox saying, okay, I've got 1,000 security logs. Oh wait, this threat might have went through to this system. Oh, it's too late. I didn't configure that policy correctly. That's the idea. We're creating this automated response up to the point where we start getting into self-remediating and self-healing networks, right? And the way that we're creating this fabric is really an expert system, right? It's taking artificial intelligence, i.e. these systems I'm talking about, like our self-evolving detection system through machine learning, deep learning, and applying that, integrating FortiGuard, my department, intelligence, into our product. So it can deliver intelligence, confidence intelligence, after we do all this machine learning I talked about, then the product can start configuring and enacting on that. And that comes down to rules on, obviously, antivirus and different things like this as well. But it's solving that problem, crossing the last mile, a big problem in the industry. We're also working to interoperate. That's a big thing about the fabric. We realize not everything's Fortinet, right? You know, I mean, that's just the world that exists out there. So how do we interoperate? How do we work together just to make it more expensive for cyber criminals to operate? We're doing that through APIs now. So on an operational level, if you have different CTI platforms, different SIMs and things like that, we have created new APIs now to open up our threat intelligence to you as well. We're also creating tactical tools. It's called a threat intelligence service, which I'll talk about quickly coming up. And on that operational level, again, how do we close that gap on the shortage of cybersecurity skill set? We need to talk and work together. So we've created the FNDN, it's a Fortinet developer network that has FortiGuard extensions. And this gives you direct access to a forum, your engineers to our engineers, one-on-one, to be able to talk, how can I get access to this API and start integrating this intelligence to get more visibility on my systems and protect against these threats. We're doing this through tokenized services, JSON APIs, where you can connect to private label our intelligence from that big data set in the background I was talking about, as well as CTI feeds. So this is sticks, In the world of cyber threat intelligence, we talk sticks, and you can get access to new indicators of compromise we're learning through the FortiGuard. We've beta launched a new service called Threat Intelligence Service. This is, provides a kill chain view of our knowledge. What is FortiGuard seeing out there in the industry? Because there's a lot of things. As I said, we get 50 billion potential threat events a day that we have to look at. So it provides a contextualized view so that you can prioritize, okay? A, what's happening on your network? B, is that a big deal? Does it compare to global stuff we're seeing? C, is that a big deal to other, other organizations in your vertical as well? What this really is a tool so that a CISO and even your SOC and your network admins can start prioritizing, saying, I know we have 100 threats, but here are the top 5 ones, and these are why they're critical, and here's how we respond to it. Right? That's where the repurposing of humans come into after you start applying that automation and intelligence. Finally, another way we're interoperating here is through the Cyber Threat Alliance. So Fortinet's a founding member. I've been there since day one. I wrote the original bylaws, and we work with our other founding members, as you can see in the logos up on the slide. I'm on the steering committee and work with the board. We're bringing on new members. You're going to hear about new announcements, and this is ways that we can actually level the playing field if you're interested in cyber threat intelligence. Certainly come talk to me. I'd be more happy to introduce you to this model as well. It's a platform that we've implemented to be able to allow that crossing the last mile problem, and it's also a great resource of some of the best minds in the industry as well to get connected to. I think I'm right on time, so with that, I'd like to really thank you for your time. It's been a pleasure talking. We're going to have, I think, a great panel coming up. And as you can tell, I'm really passionate about this stuff. But again, just think about this. We're in a very opportunistic time, but we have to act now. Okay? Thank you very much.